Joseph Paxton is a kind of quintessential British hero of those years, insofar that he had no traditional training. He was neither an engineer nor an architect, but actually somebody who had risen pretty much by himself. Queen Victoria was to call him a gardener in a dismissive way in her memoirs. Actually, Joseph Paxton was far more than a gardener. He was somebody indeed interested in botany, but somebody who'd realized construction of all kinds, somebody also who launched press enterprises. He created a couple of journals. And above all, and that's true, he was a gardener in that respect, he had become the chief gardener of the Duke of Devonshire and responsible for the management of the main estate of the Duke in Chatsworth. Chatsworth was a magnificent castle, but it hosted a very large botanical collection. The Duke himself commissioned expedition to bring tropical species and acclimate them in Chatsworth. If Chatsworth is mostly known today for its beautiful grounds, it was also a highly experimental place where Paxton realized in particular two experimental greenhouses which will play a role in the initial design of the Crystal Palace. Paxton's main realization in Chatsworth was the Great Stove, a giant greenhouse started in 1838 and completed in 1840. It was at the time one of the largest greenhouses ever built. The Great Stove was not only important because of its dimension, but because also of a number of technological achievements, among which the use of very large sheets of glass, very different from the smaller pieces that had been used before Paxton. Paxton worked actually in close relation with the Chance Brothers Company, a company who produced glass, and actually the Chance Brothers Company will be working for the Crystal Palace. The Great Stove has disappeared today, but it was much admired by the contemporaries, among other things, not only because only of the technology, but also its sheer size. You have to imagine that it was as high as the vaults of a Gothic church, something quite impressive, which enabled the greenhouse to host trees inside. Here we have, for example, a drawing made by a German architect while touring Chatsworth, which says a lot about the kind of European-wide reception of Paxton's work. So, gardener perhaps according to Queen Victoria, but a gardener of a very special and elevated type. Another key realization of Paxton at Chatsworth was the 1850 lily house that he built to host the giant lily plant called the Victoria regia. This was actually a very rapidly growing plant which entailed actually rebuilding an entire greenhouse for it alone. There, Paxton actually used a completely innovative roof principles using much longer sash bars supported by cast iron trusses that would actually be the very principle for the Crystal Palace roof techniques. One of the key intuition behind the Lily House was that a great resistance could be achieved by thinking of structure not necessarily in terms of very large and massive structural members, but through a more web or lattice-like way of thinking. Something that was inspired allegedly to Paxton by the very lily flower he had to shelter in the Lily House. Here we have Paxton's daughter sitting on one of the leaves of the Victoria regia, and these leaves were rigidified through this kind of intricate web, which was a source of inspiration for Paxton. And the whole Lily House is actually a complex system that functions a little bit like what we would call today a kind of space structure. As we can see here, they're relatively long sash bars, which are supported by cast iron girders, but the whole thing functions a little bit like a web, which was one of the principles at work in the Crystal Palace. Here we have a more detailed view of the Paxton roofing principle, which is, may look simple, but which is full of refinement. For example, the wood beam actually rigidified electrified through iron cables, a little bit like a truss. You may note also the grooves at the base of the wood beams. They are actually meant to allow for the water produced by condensation to be evacuated. The genius of Paxton lies not only in the general conception of his building, but also in the kind of very close attention paid to details. And as we will see, details at the scale of the Crystal Palace become no longer negligible. I have insisted on the use of large sheets of glass by Paxton, glass produced by the Chance Brothers factory. It's quite interesting that glass, which is with iron one of the most emblematic materials of the industrial era, remained relatively artisanal. It was blown. Typically, people blew cylinders that were then opened and flattened in order to produce sheets of glass. While iron, of course, knew very important transformation in terms of processing. We understand also that, a process like the first industrial revolution is actually a mix of, very spectacular technological advances and more incremental, more minute changes like those that characterize glass manufacturing. So how did Paxton enter the story of the Great Exhibition? Actually, through a series of serendipitous coincidence. Paxton actually had begun sketching. He was actually appalled by the official scheme of the committee in charge of the exhibition and imagined that actually a greenhouse like solution would actually function much better at that scale, and especially would be lighter and less expensive. He had begun to sketch, and here is one of the most famous sketches in which we find the principle of the Crystal Palace. It's a kind of cross-section, and it's a kind of giant lily house with the same roof principles, but of course at a completely different scale. Among the many interests of Paxton, one found railways. Once again, he was a very special kind of gardener, and he had become an expert in railways. And he had traveled in order to participate to a discussion at a trial regarding some kind of contentious issues on railway construction and management. And traveling back to London, he met with one of the members of the committee, Robert Stephenson, the famous engineer who had been involved in a number of enterprises, railway, but also bridges. He's the author of the Britannia Tubular Bridge. And Paxton showed his scheme to Stephenson, who got completely enthusiastic and thought that this could be the solution to the conundrum in which the committee found himself. So Stephenson did encourage Paxton to actually submit his proposal for the realization of the grid building of the exhibition. There was only one problem, which is that the call for proposals were actually proposals to build the project elaborated by the committee. Fortunately, there was in the contract, it was stipulated that if the companies, the building companies had an alternative idea that was cheaper, they could actually submit it in parallel with the proposal to build the project of the committee. So Paxton partnered with a firm called Fox and Henderson and proposed his scheme as an alternative to the construction of the committee. Paxton's proposal was roughly 60 to 80% cheaper than building the project in brick and with brick and mortar of the committee. But it was not only cheaper, it was actually much more seductive, and the images published by the press immediately gathered momentum around what appeared more and more as the solution to the difficult problem of how to host the Great Exhibition. Let's not forget that we're in something like in June 1850, and they're barely 1 year and a half in order to complete the construction, to open the exhibition. So actually things were pretty much in rush. This image published in the press is actually the first version of Paxton project. As we can see, this is a very repetitive buildings in which there is a certain indistinction between the various parts of the building, something that was wanted by Paxton. In some ways, the Crystal Palace also marks the emergence of a totally new idea in architecture, which is the idea of flexibility. An idea that we there again become completely accustomed to. Flexibility seems, a key notion when thinking in terms of very large building. But once again, this was the first time that such ideas ever emerge. Another thing to notice, there is no transept, contrary to the final buildings in which we can see a transept with a barrel vault in the middle of the building. The transept was actually an idea that emerged at the intersection of a couple of concerns. One was that the ground on which the building was to be constructed was actually leased, but had to be brought back in its initial shape. And there were a number of trees on that ground, and the British are very attached to trees, as we all know, so trees had not to be destroyed. So there was a problem on how actually to put the trees inside the building, so the additional height provided by the barrel vault was a solution, an elegant solution to that. A second role played by the transept was actually to improve a little bit the lateral bracing. It did improve the bracing, but one has to say that actually Paxton and Fox and Henderson, its builder, were quite lucky because the bracing was still pretty imperfect, and had a storm or something happened, the Crystal Palace could have been in serious trouble. This was a building very rapidly designed and with a number of structural flaws that have become evident to the eye of historians studying retrospectively how it was designed. I said that the building was enormous. It covered on the ground something like 800,000 square feet, something quite unheard of at the time. In addition to that, a second floor brought some additional 200,000 square feet. So in total, it was almost 1 million square feet, something that enabled to display all the artifacts that had been secured by the committee, the organization committee for the Great Exhibition, but there again, something that one had never seen before that building.